So for 5.4, so for unit 5.4, we're going to add, subtract, multiply, and divide complex numbers. Okay, so basically all different operations with complex numbers. Now, whether or not you realized it, there are actually a bunch of different types of numbers that you can encounter. There's a poster up on the wall that shows you all the different kinds of numbers, right? But complex numbers basically encompasses just about everything, okay? So you need to know that the standard form of a complex number and how your answers need to be written, okay? So standard form of a complex number, okay, the standard form of a complex number is A plus BI, okay? A plus BI. You guys see that okay? You good? Pretty much. Okay. The A portion is the part that is real. So a complex number is made up of part of a real number and part being an imaginary number. So this is the real part. Okay, this is the part that is a real number. And real numbers are basically numbers that you could plot. Okay, so real numbers are like positives, negatives, fractions, decimals, percents, okay, anything like that. Okay, so any number that you basically can think of except for I is a real number, basically. Okay, and the BI part is the part that's imaginary. So complex numbers are made up of part that is real and part that is an imaginary number. Okay, we always write the real part first, the imaginary. I have no idea what I was writing there. Okay, I am a imaginary. Don't know why there's a P in there. Part imaginary. So part of it is real, part is imaginary. A little bit easier for you to see. So part imaginary and part real numbers. So it's just going to simply ask you to simplify. There's not going to be any solving today. So simplify. For example, number 1, if I ask you to find the sum of 7i minus 8 and 5 minus 3i. Find the sum of 7i minus 8 and 5 minus 3i. Find the sum of those. What does sum mean? What am I actually asking you to do here? Sum means addition. So add them all together. So literally just rewrite this, 7i minus 8 plus 5 minus 3i. Okay? You always want to add together the real parts and the imaginary parts. So this is basically combined like terms. So we're going to do the real parts together and the imaginary parts added together. And when you write your answer, I want you to write it in standard form. So standard form means the real part first. So negative 8 plus 5 give you what? Negative 3. And then the imaginary part, 7i minus 3i, is what? Plus 4i. That's your answer. Okay, we're just adding together like terms. So negative 3 plus 4i is the sum. Okay, next one, number 2. I would like you to simplify 3 minus I minus 5 plus 2i. 3 minus I minus 5 plus 2i. Three minus I minus 5 plus 2i. So for this one, you're basically needing to distribute. So distribute the negative, then line them up. So 3 minus I minus 5 minus 2i. Make sure you distribute all the way through and that you don't stop halfway. Then it's just combine like terms. So which are the like terms here? which are your like terms here? And which ones should you add together first? The real parts first. So 3 minus 5 gives you what? Negative 2. And then the imaginary part, negative I minus 2I gives you what? Minus 3I. Okay, this is like a negative 1 minus 2, so negative 3I. That's your answer. Okay, once it's written in standard form, and if you do it backwards, that's fine. You just have to rearrange it. Okay, so it's not a big deal if you write it in a backwards form to start with. You can always fix that. Okay, for number 3, this one's a little bit more complicated. Okay, how about if we did 6 plus 2I minus 4 times 5 minus 3I plus 2I times 7 minus 5I. 6 plus 2I minus 4 times 5 minus 3I plus 2I times 7 minus 5I. So this one, again, just a bunch of distributing. So make sure that you distribute the sign with each number. So the negative does go with the 4, and then the 2I is going to distribute. So rewrite this. This is basically 6 plus 2I. Negative 4 times 5 gives you minus 20. Negative 4 times negative 3I is a plus 12I. 2I times 7 gives you plus 14I. And then 2I times negative 5I is negative 10I squared. Before you can combine like terms, though, we actually need to simplify. Okay, so what is negative 10I squared? What happens when you have an I squared? It turns to be positive. So this goes away. Negative 10 times negative 1 turns this into a positive number. Okay, so simplify before you add all the like terms. It just makes it a little bit easier. Then we're going to add together all the like terms. So add together all the real numbers and add together all the imaginary numbers. So if we add together the real numbers, 6 minus 20 plus 10 gives you what? 6 minus 20 plus 10 is what? Negative 4. Then 2I plus 12I plus 14I, gives you what? 2 plus 12 plus 14 plus 28I. And you're done. Right? You don't have to factor, take out a GCF, nothing like that. Just leave it just like this in what's called standard form. Questions so far? Okay, now, so we've done some addition, some subtraction, a little bit of both. Now let's move on to some multiplication. So for multiplication, how about if I ask you to simplify 5I times 8 minus 4I? 5I times 8 minus 4I. times 8 minus 4I. This one's essentially just distributing, so multiply across. Negative 5I times 8 gives you what? Negative 40I. Negative 5 times negative 4 gives you a positive 20I squared. Then what happens with the I squared? Turns it negative. So basically just rewrite this, and in standard form, you want the whole number first, so negative 20 minus 40I. That's your answer. Questions so far? Easy? Difficult? Half asleep? Awesome. Good to know I'm doing my job. Okay, let's try another one. Number 5. Okay, let's try 1 plus 3I times 3 plus I. 1 plus 3I times 3 plus I. Any ideas? How are you going to do this? FOIL. First, outside, inside, last. Okay, so first times first gives you what? 3. Outsides is a plus 1i. If you don't write the 1 in front, that's fine, but you can. Insides is a plus 9i. And last gives you what? Plus 3i squared. 3i times I gives you a plus 3i squared. Then convert this to simplify, or simplify this, okay? So 3i squared actually becomes what? Negative 3, and then combine your like terms. What happens with your real numbers? They cancel each other out. Positive 3, negative 3, they completely go away, and that's fine, okay? Then just add together your like terms, so add together the i's. 3i and 9i just becomes 10i. That's your answer. Okay, just a 10i. So it's just combined like terms. Okay, just because it has i's in it does not make this any more difficult. Okay, I promise it does not need to make it any more difficult. Okay, number 6. Say it again. Huh? I know, it's warm. Sorry. Number 6. Let's try 9 over 7i plus 5 over 7i. 9 over 7i plus 5 over 7i. This one, in order to add together fractions, they have to have a what? Common denominator. Do these have a common denominator? Yes. So when they have a common denominator, you add the numerators. So 9 and 5 gives you 14. Keep the denominator the same. Those do not add. They do not multiply. Nothing like that. Then, what is 14 over 7i? What's wrong with this right now? Number 1, it's not reduced. Number 2, you can't have i's in the denominator. But you definitely want to reduce first. Okay, so 14 over 7 reduces to be 2 over 1. Then we can't have this. Okay, so 2 over I, how do I get rid of the I in the denominator? Rationalize it, yeah, so multiply by I over I. If you multiply in the top, we get you 2i over I squared. Then simplify again. What is I squared? A negative 1. And would you write this as 2i over negative 1, or how would you write it? Just negative 2i, right? That's the answer that I'm looking for. Okay, almost done with this type. And again, I apologize, these are kind of long, but there's a lot of different kind of parts of this objective. So 1 minus 3i divided by negative 2 minus 4i. 1 minus 3i divided by negative 2 minus 4i. So in order to get rid of the radical in the denominator, what do you have to multiply by? What's it called? Starts with a C. The conjugate. Okay. The conjugate here, remember the conjugate, the only thing you're changing is just the middle sign. So the conjugate here is actually negative 2 plus 4i. But the negative 2 stays just like it is. So negative 2 plus 4i. All you're changing is the middle sign. Okay, not the first one, just the middle sign. Then you actually have to FOIL. So here we're going to have to FOIL twice. We FOIL in the numerator. So if you FOIL the top, negative 1 times negative 2 gives you negative 2. Outsides gives you plus 4i. Insides gives you what? Plus 6i. And last is negative 12i squared. Then you're going to FOIL again in the denominator. So first times first is a positive 4. Outsides gives you minus 8i. Insides is plus 8i. And last is what? Negative 16i squared. You want to simplify. So here, first you want to simplify the I squared. So what does negative 12i squared become? Positive 12. In the denominator, negative 16i squared becomes what? Positive 16. Okay, so in the numerator, negative 2 and positive 12 gives you what? Negative 2, positive 12 is 10. Okay, then add together your i's. 4i plus 6i gives you plus 10i. In the denominator, 4 plus 16 is 20, and negative I, positive 8i, these cancel out, which is what you want. Okay, we want these to go. We want to eliminate the i's in the denominator. Oh, it would be helpful if you guys could see this, sorry. Then, anytime something's going to reduce, you actually need to separate these, okay? So you need to make two fractions. This will become 10 over 20 plus 10i over 20. And the reason you want to separate them is because sometimes, or a majority of the time, your denominators will end up different. In this case, they end up being the same. But a lot of times you can reduce them differently. So what would 10 over 20 reduce to be? 10 over 20 is what? 1/2. Plus, what's 10i over 20? I over 2. And if you write 1i, that's fine. That's the answer that we're looking for. And on your test, these are written as separate fractions. So that's why I'm showing you how to write it separately. Any questions on any of that? Okay, next thing we're going to work on is graphing complex numbers. It's really not that bad. Graphing complex numbers. Okay, when you're graphing complex numbers, you need to know that it's just like an XY axis, okay? But instead of being the x-axis, this is called the real axis, and instead of being a y-axis, this is the imaginary axis. Alright, so here, if I asked you to graph, sorry, run number 8. Okay, I want you to graph, and we can graph all of these on the same plane. Okay, let's graph -2 plus 4i, as well as 2 minus 2i. And let's do 3i and -4i. So -2 plus 4i, 2 minus 2i, and positive 3i and -4i. So what you do is you graph this, you write these just like an ordered pair, and it's always real, comma, imaginary. Okay, we always write this as real, comma, imaginary. So this ordered pair is actually at the real part is -2, comma, the imaginary part is 4. So we're going to graph them just like that. Okay, here the real part is +2, the imaginary part is -2. These are a little bit more difficult because what's the real part here? 0, comma, the imaginary is 3. And here this is 0 for the real part, comma, -4. So when you graph these, you graph them just like a normal XY axis, okay? But it's always real then imaginary. So we're going to put 4 spaces in each direction. And make sure when you're doing these that you label them as well. Okay, so -2, 4. Right here, this is -2 plus 4i. Then 2 minus 2i would be here. It's just like 2 -2. So this is 2 minus 2i. And we don't write these in parentheses. Okay. 3i would be over 0 up 3, so that's 3i. And -4i is down here at -4i, just like that. That's how we graph complex numbers. Questions on how I did that? Everybody caught up to here? Okay, and then the last thing that we're going to do is simplifying with i's. Okay, so simplify involving i's. We'll say involving imaginary numbers. Okay, so simplify involving imaginary numbers, okay? You know that by definition, we did this the other day, okay? That by definition, I to the first is equal to I. Makes sense, right? What did we say was I squared? I squared is equal to what? -1. What would be I to the third power? How would you figure out I to the third power? Would you agree that I to the third is made up of I squared times I? Would you agree with that? What is I squared? Negative 1 times I to the first is just I, so this would equal negative I. So I to the third is equal to negative I. And you could find that because you could find its components and then add all the things together. Or find all the components and then come up with a definition. Okay? How about I to the fourth? What would I to the fourth equal? How could you make up I to the fourth? I squared times I squared. I squared we said was negative 1 times another negative 1. So I to the fourth actually becomes a positive 1. Okay? Now, anything past 4, it repeats. So what I'm going to teach you is a shortcut here. Okay? And I want you to write this down. So this is the definition, but I'm going to teach you the shortcut way. Okay? So this is why this works. But what I want you to write down is I to the first equals I squared equals I to the third equals, and I to the fourth equals. I'm going to teach you a saying that you probably might laugh at, but it will be helpful. Promise. So get these 4 written down, and then we're going to fill it in. Got it? Okay. The way you fill this in is you first write down the first 4, then you write it. Now I want you to, don't write it yet, I want you to watch how I do this. Okay, so watch it while I'm saying it. Okay, so while I say it, I'm filling it in. Okay, the way we do this is I won a negative sandwich. So we sandwich the 2 negatives in the middle. That's how you fill out that chart. Okay, I won a negative sandwich. And we just made this without having to figure stuff out like that. Now, that doesn't seem like it really matters, okay? Except that, what if I asked you to simplify for, what number are we on? Number 9? Are we on 9?
Yeah.
Okay. For number 9, if I asked you to simplify I to the 13th. Simplify I to the 13th power. So, if you don't know this, or as of right now, you don't really know what this is used for. So, I to the 13th would be equal to what? How many groups of 4 could I break it down to? 3 groups of 4, and then 1 extra. We know that I to the 4th is equal to what?
1.
A 1, and 1 cubed times I equals what? I. Now, you can do that, and that is a totally legitimate way of simplifying these. Or, the shortcut is, if you know this pattern right here, you can count them, literally. If we want to get to I to the 13th, you literally just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you're done. So just by using the chart, you can tell what it is. Or you can use this process, and you can get your answer that way. But you can use this chart to literally just count. Okay? On your test, you're not going to have to go to like crazy numbers. Okay? On your homework, I think there's one that's like 27. You can count it. You'll be fine. Just count up to 27. You know your numbers. Okay? But this chart is going to be very helpful for you. Okay? Now, what if I ask you to simplify? I have 2 more for you. Okay? I want you to simplify for number 10. Simplify 4i to the 9th. 4i to the 9th power. So literally, the number in front is just going to stay a 4. And you're going to multiply it by I to the 9th. So to find I to the 9th, go to your little chart that you made, the I want a negative sandwich chart. Okay, and it might help you if you actually write I won. And you have to say it very like enthusiastically. I won a negative sandwich, like you won like a jackpot. So it's awesome. This is your math jackpot. You guys are looking at me like I'm crazy. I won a negative sandwich. Yay! I won a negative sandwich. So, to the 9th, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I to the 9th is I. 4 times I, 4i. That's your answer. It's really supposed to be easy. I'm trying to make it as easily as possible for you. 4i. Last one. Okay, I promise this is the last one. Number 11. Okay, I would like you to simplify negative 5i cubed times 4i squared. Negative 5i cubed times 4i squared. So for this one, these are both monomials, so there's no plus or minus attaching them. So multiply your numbers. Negative 5 times 4 gives you what? Negative 20. What do I do with my exponents on the I? Add them. So 3 plus 2 gives you 5. And that can further be simplified to be what? Negative 20 times I to the 5th is what? 4, 5. I. Negative 20 times I gives you negative 20 I. That's your answer. Questions on how I did that? Hopefully it's not too bad. Okay, homework for this. There is a little bit, it looks like a lot of homework, but it's really not that bad. Sorry, you're doing worksheet 4, numbers 1 through 17 odd. However, you're going to skip number 7. Number 7. As well as you're working on page 279, you're doing numbers 13 to 41 odd. And I know that seems like a lot, but a bunch of these are just plotting them. You can plot or graphing things all on the same plane. That's fine. So that's pretty easy. And then there's a bunch of these where you're just figuring out like I to the power. Not like that. Okay, anyone have questions? This lesson is the majority of your test, obviously, since I did a bunch of stuff on it.